Hello guys, welcome to another episode of my video tutorial. And for this episode we'll be looking at the 500 watts 12 volt square wave inverter. Yeah, it's a square wave inverter, and for this very episode I want this video to be as short as possible. So without any further ado, let's get started. A while ago, when I say a while, about 2 years ago, I bought two of those high frequency inverters from eBay, and I actually wanted to use them for experiment. So I bought two in case one fails, the other will continue. I actually used one for the experiment, and I was about to salvage the components from this since it won't be useful anymore, but then I decided to make this video. Alright, I'm sure this is actually looking very familiar to some of you who purchase things online, electronics components. This is said to be a 500 watts inverter, 500 watts, but literally this is a 250 watts inverter. And that's because it has a power factor of 0.5, and if you do 500 times 0.5 you get 250. So this is actually 250 watts inverter in reality. Then looking at the simplicity of the inverter, you will notice for MOSFETs here, these are IRF 3205 MOSFETs, and they are actually configured in the push-pull configuration. Two parallel, so push-pull configuration. On the driver IC we have the SG3525 driver IC. Here we have the very high frequency transformer. We'll talk about the frequency in a bit, but then the inverter takes in 12 volts and it can spit out up to, is it 320 volts or something? I'll put it on the screen. So here, looking at the back, you can actually see the thick soldering parts here, very thick, and the aim is actually to accommodate more current. And here you can see the MOSFETs. They are literally parallel, so two are connected together and these other two are connected together, and they actually give it the push-pull effect to create the square wave, the negative and positive circle. So let me connect some wires to the input and the output, and then we'll run some tests. Alright guys, so I have actually soldered out the wires. Let me zoom out a little bit. Okay, so I've soldered the wires. Here is my negative line, this is the positive, and you can actually see the negative here, positive here, and then here I soldered the switch. So these wires will serve as a switch to put it on and off. And here is the output. You can see closely, 0 volts to 20, 380. So I have soldered also this wire from the 0 volt and the 220 volt terminal. This will be connected to the incandescent bulb, and I think that's that. So let's go ahead and test it. Alright, for test purpose I'll be using this battery, Panasonic 7.2 amp hour battery for the test. So first I connect the negative line. This is just for test purpose, so it doesn't really have to be firm, but also you have to make it as firm as possible. And then the output will be connected to this incandescent bulb, and this is actually 100 watts. So I will connect this to the output. All right, so for the testing, I would like to use my multimeter, but the frequency of this inverter is so high, I really doubt my multimeter can measure the voltage. Now, talking about the frequency, this inverter, something I would rather call abnormal inverter. No, not abnormal inverter, actually. This is a high frequency inverter, and this operates at 20 kilohertz, while the normal inverters operate between 50 hertz to 60 hertz, depending on the region they are being used. But this is 20 kilohertz, and for those of us not familiar with the frequency measuring stuff, 20 kilohertz is 19,940 times higher than what you require if you are using 60 hertz, and then 19,950 times higher than what you require if you are using 60 hertz. And this is one crappy pack that came with a bulb, and here you can actually see it's rated 50 hertz, and this is actually what the bulb is rated for, but it will work. I just can't measure voltage with this meter. All right, so let me turn it on. 1, 2, ready, go. Oh yeah, works, right? All right, so the lamp is on. Let me try to see if I can measure voltage. 0 volt, 220. Oh, it's trying. The voltage is 150. Let me see this other one. Oh, that's out of range. Okay, so this is 140. It's fluctuating seriously. There's no feedback. And here we have 170, whatever, it's fluctuating. Here's the lower side, 12 volts. 12 volts, the lower side, and the other one 268, and this is 152. And this voltage is actually fluctuating because there is no feedback, so there is no output voltage control. Anyway, so this is my rather short video for this weird inverter, and now I'm going to take apart everything, remove the entire MOSFET, the transformer, the driver, and use them for a better inverter. Okay, so I'm actually working on something that will require this. So I have this very big transformer. I think it's rated 3.5 kV or something like that. I'm not very sure, but I'm working on something which you guys will see soon. But till then, thanks for watching. See you in the next video.